Michael Faraday, who came from a very poor family, became one of the greatest scientists in history. His achievement was remarkable in a time when science was usually the preserve of people born into wealthy families. The unit of electrical capacitance is named the farad in his honor, with the symbol F. Michael Faraday was born on September 22, 1791 in London, England, UK. He was the third child of James and Margaret Faraday. His father was a blacksmith who suffered poor health. Before marriage, his mother had been a servant. The family lived in a degree of poverty. Michael Faraday attended a local school until he was 13, where he received a basic education. To earn money for the family, he started working as a delivery boy for a bookshop. He worked hard and impressed his employer. After a year, he was promoted to become an apprentice bookbinder. Michael Faraday was eager to learn more about the world. He did not restrict himself to binding the shop's books. After working hard each day, he spent his free time reading the books he had bound. Gradually, he found he was reading more and more about science. Two books in particular captivated him: the Encyclopaedia Britannica, which is his source for electrical knowledge and much more. Conversations on Chemistry. Basically, it's chemistry for dummies. He became so fascinated that he started spending part of his meager pay on chemicals and apparatus to confirm the truth of what he was reading. As he learned more about science, he heard that the well-known scientist John Tatum was going to give a series of public lectures on natural philosophy, physics. To attend the lectures, the fee would be 1 shilling, too much for Michael Faraday. His older brother, a blacksmith, impressed by his brother's growing devotion to science, gave him the shilling he needed. Faraday's education took another step upward when William Dance, a customer of the bookshop, asked if he would like tickets to hear Sir Humphry Davy lecturing at the Royal Institution. Sir Humphry Davy was one of the most famous scientists in the world. Faraday jumped at the chance and attended 4 lectures about one of the newest problems in chemistry, defining acidity. He watched Davy perform experiments at the lectures. This was the world he wanted to live in, he told himself. He took notes and then made so many additions to the notes that he produced a 300-page handwritten book, which he bound and sent to Davy as a tribute. At this time, Faraday had begun more sophisticated experiments at the back of the bookshop, building an electric battery using copper coins and zinc discs separated by moist, salty paper. He used his battery to decompose chemicals such as magnesium sulfate. This was the type of chemistry Humphry Davy had pioneered. In October 1812, Faraday's apprenticeship ended, and he began work as a bookbinder with a new employer, whom he found unpleasant. And then there was a fortunate accident. Sir Humphry Davy was hurt in an explosion when an experiment went wrong. This temporarily affected his ability to write. Faraday managed to get work for a few days taking notes for Davy, who had been impressed by the book Faraday had sent him. There were some advantages to being a bookbinder after all. When his short time as Davy's note-taker ended, Faraday sent a note to Davy, asking if he might be employed as his assistant. Soon after this, one of Davy's laboratory assistants was fired for misconduct, and Davy sent a message to Faraday asking him if he would like the job of chemical assistant. Would he like the job? Working in the Royal Institution, with one of the most famous scientists in the world? There could only be one answer. Faraday began work at the Royal Institution of Great Britain at the age of 21 on March 1, 1813. His salary was good, and he was given a room in the Royal Institution's attic to live in. He was very happy with the way things had turned out. In 1816, aged 24, Faraday gave his first ever lecture, on the properties of matter, to the City Philosophical Society. And he published his first ever academic paper, discussing his analysis of calcium hydroxide, in the Quarterly Journal of Science. In 1821, aged 29, he was promoted to be Superintendent of House and Laboratory of the Royal Institution. He also married Sarah Barnard. He and his bride lived in rooms in the Royal Institution for most of the next 46 years, no longer in attic rooms. They lived in a comfortable suite Humphry Davy himself had once lived in. In 1824, aged 32, he was elected to the Royal Society. This was recognition that he had become a notable scientist in his own right. In 1825, aged 33, he became director of the Royal Institution's laboratory. In 1833, aged 41, he became Fullerian Professor of Chemistry at the Royal Institution of Great Britain. He held this position for the rest of his life. In 1848, aged 54, and again in 1858 he was offered the presidency of the Royal Society, but he turned it down. Funnily enough, although in Faraday's lifetime people had started to use the word physicist, Faraday disliked the word and always described himself as a philosopher. He was a man devoted to discovery through experimentation, and he was famous for never giving up on ideas which came from his scientific intuition. If he thought an idea was a good one, he would keep experimenting through multiple failures until he got what he expected, or until he finally decided that Mother Nature had shown his intuition to be wrong, but in Faraday's case, this was rare. Here are some of his most notable discoveries. Discovery of electromagnetic rotation. This is a glimpse of what would eventually develop into the electric motor, based on Hans Christian Ørsted discovery that a wire carrying electric current has magnetic properties. Electricity flows through the wires. The liquid in the cups is mercury, a good conductor of electricity. In the cup on the right, the metal wire continuously rotates around the central magnet as long as electric current is flowing through the circuit. Gas liquefaction and refrigeration. In 1802, John Dalton had stated his belief that all gases could be liquefied by the use of low temperatures and/or high pressures. Faraday provided hard evidence for Dalton's belief when he used high pressures to produce the first ever liquid samples of chlorine and ammonia. The ammonia liquefaction was of further interest, because Faraday observed that when he allowed the ammonia to evaporate again, it caused cooling. The principle of cooling by artificial evaporation had been demonstrated publicly by William Cullen in Edinburgh in 1756. Cullen had used a pump to reduce the pressure above a flask of ether, causing the ether to evaporate quickly. The evaporation caused cooling, and ice formed on the outside of the flask as moisture from the air came into contact with it. The importance of Faraday's discovery was that he had shown that mechanical pumps could transform a gas at room temperature into a liquid. The liquid could then be evaporated, cooling its surroundings, and the resulting gas could be collected and compressed by a pump into a liquid again, then the whole cycle could be repeated. This is the basis of how modern refrigerators and freezers work. Discovery of benzene. Historically, benzene is one of the most important substances in chemistry, both in a practical sense, for instance, making new materials, and in a theoretical sense, for example, understanding chemical bonding. Michael Faraday discovered benzene in the oily residue left behind from producing gas for lighting in London. Discovery of electromagnetic induction. This was an enormously important discovery for the future of both science and technology. Faraday discovered that a varying magnetic field causes electricity to flow in an electric circuit. For example, moving a horseshoe magnet over a wire produces an electric current, because the movement of the magnet causes a varying magnetic field. Previously, people had only been able to produce electric current with a battery. Now Faraday had shown that movement could be turned into electricity, or in more scientific language, kinetic energy could be converted to electrical energy. Most of the power in our homes today is produced using this principle. Rotation, kinetic energy, is converted into electricity using electromagnetic induction. The rotation can be produced by high-pressure steam from coal, gas, or nuclear energy turning turbines, or by hydroelectric plants, or by wind turbines, for example. Discovery of the Faraday effect, a magneto-optical effect. This was another vital experiment in the history of science, the first to link electromagnetism and light, a link finally described fully by James Clerk Maxwell's equations in 1864, which established that light is an electromagnetic wave. Faraday discovered that a magnetic field causes the plane of light polarization to rotate. When the contrary magnetic poles were on the same side, there was an effect produced on the polarized ray, and thus magnetic force and light were proved to have relation to each other. Michael Faraday died aged 75 on August 25, 1867 in London. He was survived by his wife Sarah. They had no children. He had been a devout Christian all of his life, belonging to a small branch of the religion called Sandemanians. During his life, he was offered burial in Westminster Abbey along with Britain's kings and queens and scientists of the stature of Isaac Newton. He turned this down, in favor of a more modest resting place. His grave, where Sarah is also buried, can still be seen in London's Highgate Cemetery. He, of course, was given the ultimate accolade by appearing on the reverse of the Series E £20 Bank of England note. Although coming from a poor family, Michael Faraday would work tirelessly to first educate himself. He would then dedicate his life to the pursuit of knowledge. His tenacity would see him become one of the world's most important scientists. His achievements are even more remarkable given his humble beginnings in a world dominated by the privileged class. Nature is our kindest friend and best critic in experimental science if we only allow her intimations to fall unbiased on our minds. So, if you enjoy this kind of videos, please hit the subscribe and like button and we'll see again in the next video.